In this question statement, we have to determine the temperature of the outer surface of a particular body. First of all, let me just read the question statement. An aluminium pan whose thermal conductivity is given, which is 237 watt per meter per degree centigrade, and which has a flat bottom with a diameter of 20 centimeters and a thickness of 0.4 centimeters. Heat is basically transferred steadily to the boiling water in the pan through its bottom at a rate of 800 watts. If the inner surface of the bottom of the pan is at the temperature of 105 degrees centigrade, you have to determine the temperature of the outer surface of the bottom of the pan. After reading this question statement, let us just have a look on the diagram and we'll try to understand the problem statement. This is actually a pan and heat is being provided from the bottom, and the heat transfer rate is 800 watts, and the diameter of the bottom of this pan is 20 centimeters and the thickness is 0.4 centimeters, and the inner temperature of this pan and the inner surface temperature of this pan is 105 degrees centigrade. You have to determine this outer temperature of this pan. Before going into the details of the solution of this problem, let us first of all take some assumptions. That the first assumption is the steady operating conditions exist since the temperature or the surface temperatures of the pan remain constant at the specified values, and the thermal properties of the aluminium pan are constant. So the next concern is the thermal conductivity of the aluminium pan, which is given, and the thermal conductivity is represented by K, and it is given in the question statement, that is 237 watt per meter per degree centigrade. So the first thing is that we have to determine the area of the bottom of the pan. So it is in a round shape. The area of the pan or the shape of the pan is in round shape, so we can use this formula, that is pi r square. So we are given with the diameter, that is we are given with a diameter of 20 centimeters. So if we take the half of the diameter, which will be equal to the radius of this circular pan. So if we convert the diameter into radius, the radius will be 10 centimeters, and if we convert the 10 centimeters into meter, that will be equal to 0.1 meter. If we put the values of pi and the radius of the pan in meter units, we will have the area of the bottom of the pan is 0.0314 meter square. Under the steady state conditions, the rate of heat transfer through the bottom of the pan is actually due to the conduction process, and we have to use this formula, that is the heat transfer rate is equal to the thermal conductivity multiplied by the surface area multiplied by the temperature difference over the thickness of the bottom of the pan. So we are given with the heat transfer rate, thermal conductivity, and we actually have determined the surface area in the previous slide, and we are also given with the thickness of the pan. So after putting all the values in this formula, so this is 800 watt given in the question statement, 237 is the thermal conductivity, and 0.0314 meter square is the surface area, which is also given in the question statement. The inner surface temperature is also given, right, and that is 105 degrees centigrade. And the last thing is, that is the thickness of the bottom of the pan, which was given in the question statement, that was 0.4 centimeter, and if we convert the 0.4 centimeter into meters, that will be equal to 0.004 meters. And if we put all the values in this formula, and ultimately you have to determine the outer temperature or outer surface temperature of the pan, and after simplifying that you will get the answer of the temperature that will be 105.43 degrees centigrade.